Geometry, Chapter 3, Section 3, Proofs with Parallel Lines. So in our previous section, we talked about having parallel lines cut by a transversal. And that's going to form 8 different angles. And each of those has a specific relationship. We would have said that, for example, the alternate interior angles are congruent if the two lines are parallel. We're actually going to look at looking at that same statement, but finding the converse of those. And so we're going to look at we're going to look at what that means. And so let's say I had angle 4 and angle 5. Those are alternate interior angles. Let me draw that out there. Angle 4 is congruent to angle 5 because they are alternate, and I'll just abbreviate a little bit, alternate interior. What if I looked at that the other way and I said, if angle 4 is congruent to angle 5, if angle 4 is congruent to angle 5, then what's true about, let's call this line A and line B? Then what's true, how do I want to write that? I want to write then A is parallel to B. Those aren't two L's. Those are just kind of like train tracks, and that's how the book will show you that they are parallel. So they may give you the actual angles this time and show you that they're congruent and ask you to prove that the lines are parallel. And in this case, because it's the alternate interior angles, we would use Theorem 3.6, and these are found on page 127. Theorem 3.6 tells us that if two lines are cut by a transversal so that the alternate interior angles are congruent, then that makes the lines parallel. And so that would also work, obviously, for alternate exterior angles, and it would work for consecutive interior angles, and it would also work for our corresponding angles. So they give us that, and let's say in the case of consecutive interior angles, they give us that they are supplementary, then we could prove that the two lines are parallel. All right, so here's our proof. I've written it over to the right because my screen is effective, or not as effective over there, so I wanted to put the stuff that we weren't working on. And so we're going to do a 2-column proof, and we're going to be proving that G is parallel to H. And so over here, I'm going to have all of my statements and my reasons. And obviously, number 1, we're going to put that angle 4 is congruent to angle 5, and that's the given. And so just like we did in yesterday's work, now we can take a look at, well, how can I compare those two? Well, I know that if angle 4 is congruent to angle 5, then there's 2 ways we could do this. Those are alternate interior angles, and so we could use the converse theorem there. We could say that 1 is congruent to 4 using vertical angles, and then 1 and 5 are corresponding. But I'm going to take the easiest. I'm going to go with 4 and 5, and I'm going to use the converse of the alternate interior angles theorem. And so right away, given that information, I can step right to step 2 and I can prove it. And again, you don't have to memorize the theorem, but this is the alternate inverse, alternate interior. Whew, going crazy with my words. Alternate interior converse. Again, that states if two lines are cut by a transversal and their alternate interior angles are congruent, then those two lines are parallel. And that's just a little over 6 minutes. Just a few proofs will be on the work in class. And that is Chapter 3, Section 3, Proofs with Parallel Lines.